Hi, I'm Eric,
Michael.
Austin.
Brent.
and this is our field systems, and our product is Beam. And our current setup is, or the current situation at the winery is that they need to track a lot of information as things go from vine to bins to crusher to fermenter to bottle. So our process is actually to automate that process for them so that they don't have any errors in their data. Currently, what they do is they write information down, and sometimes that gets lost, sometimes it doesn't make sense, sometimes it's not accurate. So with our system, it aims to automate that process for easy use and low form factor.
So why choose Beam? We found a couple of competitors that offer similar products, but ours offers a superior cost because we're targeting the specific industry, which is viticulture. So since we're targeting just one industry as opposed to very broad applications that the other competitors offer, we're able to focus in on what is necessary for our system. Also, we're using RFID. Some of the competitors only offer optical barcodes, which have a shorter read range because you need to get a reader right up next to it to see. Also, that could potentially be covered up by dirt, which is prevalent in our viticulture application. And also lower cost because we are targeting a specific thing. Higher cost per tag since we're using RFID as opposed to an optical barcode that just requires printing out a strip of paper. Lower cost for an entire implemented system.
So this quarter, we've been focusing on one area that the people at the winery want us to focus on. So currently what we focus on is weighing the bins, storing that information, and sending it to their local computer. So essentially what we have planned is that a worker is on the forklift, and what he has to do is just to get off, he has to read the information. What we do is we have a simple button that he presses that records the tag information, the weight, the tare weight, the time stamping, and sends that to a local computer. So it's all logged on for them in a nice Excel sheet. So that's the idea of our project so far.
And here's the hardware for our system. We're using a rechargeable lead-acid battery, sealed lead-acid battery, so that we can have a long run time because our digital scale has pretty high power requirements. So that's a 12-volt system, which we regulate down to 3.3 and 5 volts for our internal electronics, which consists of a PSOC for processing, an XP for transmission, micro SD card for offline storage in the event of a wireless connection failure, and then our RFID reader with an external antenna connection. And daylight visible LED indicators for visual feedback to the driver of the forklift.
So for our power, like Brent said, we're using the 12-volt battery. It's a 2.9 milliamp hour battery, sealed lead acid. That powers our digital scale at 12 volts, and we're regulating down to 5 and 3.3 for the PSOC and the micro SD and XP. So you can see we're communicating with 3 simple UART blocks to our main components. The reader is UART, the scale is UART, and XP is UART, and we have a micro SD card, which is just an SPI interface, and all of that is being controlled by the PSOC very easily. This is our RFID reader. It's a professional industry level RFID reader. It's capable of reading 200 tags per second. It can read up to 20 feet. It's pretty power hungry, but reads take a couple milliseconds or less a piece, and we only expect 10 to 15 or so reads per day. So the power usage is actually quite minimal.
All right, so this is our state machine. Basically, we're gonna have our PSOC XP in sleep mode for most of the time, and then when the forklift operator presses the button, we go to our remote interrupt, and we see if there's a tag in range. We go for the RFID read, and there's a error code in the tag itself. So if there's no tag in range, it ends up putting out an 0402, and then we go to no tag in range state, and then we reset because it was triggered by accident. And then if not, and the check is 0, which is no errors. Then we go to the scale read. We read in the scale data, and then we go to XB transmit and we transmit it. In XB transmit, we also write to the SD card at the same time, and then for like removal storage, and then everything is reset to 0. And then the LEDs will flash if anything goes wrong. Red LEDs or green if everything's working well.
So this is our power consumption pie chart. This data is sort of expressed over a period of battery usage, I guess, from full to needing to be recharged. The RFID reader does take a large portion of that, but the scale takes the largest portion because it runs pretty constantly. Has a nominal current draw of about 100 milliamps at 12 volts. So this will give us roughly 35 hours of runtime based off of a 10 to 15 tag read per day. PSOC is almost done. Small video.
Hi, my name is Eric, and I'm a part of the R Field Systems team. For our project, we designed our system called the Beam with the UC Davis winery and the winemakers in mind at every step. Our goal was to track and store valuable information credible to the winery to automate their data acquisition at each and every step of the winemaking process. We built our system using state-of-the-art RFID technology to implement a low-power and low-cost solution in tracking data throughout the winery. From vine to bottle, our system can retrace its steps to each location in the winemaking process to recreate specific bottles of wine to perfect the already great-tasting wine here at UC Davis. Here's what our local supporter Chick at the winery had to say about his work and what we are doing.
Viticulture and Enology. I've been here for 9 years. Just built the Platinum Winery here, and we're such an advanced winery. We're always looking for new and innovative ideas to incorporate into the wineries. Varieties that we bring in, they're generally small lot varieties that come in maybe 500 to 1,000, maybe 1,500. As the grapes are brought in, they're sometimes brought in the heat of the day, so it's very time sensitive to get the bins weighed and put in cold storage or processed as soon as possible.
With our product, we know that we will make the Robert Mondavi winemaking process much more fruitful for the winemakers.
So this is our prototype unit here, where we have the scale, which is up high where the forklift driver can see it. We don't have the box, I guess, with the box with the lights.
It's right there.
Oh, okay, great.
Somewhere. It's right there.
We also had to take into consideration that this is a big, heavy piece of equipment. The bins weigh several thousand pounds. So when they push up against our unit, we don't want it to break. So we have a swing away arm here to prevent that. There we go.
With LEDs visible to the driver.
And also gives us the opportunity to have a stand up here with the solar panel to connect the scale. With the solar panel, this could run potentially indefinitely. Any questions?
How close does the forklift driver have to get in order to?
This will read up to 20 feet. We have it kind of tuned down a little bit. We've chosen specific tags that actually won't read from very far away. So what do we find?
I think it's a foot.
2 to 3 feet.
It's exactly 1 foot with the low power setting, which is what we're using.
And our
and
bins
the
are
tags we're using.
like 4 feet by 4 feet. So with the range that we have set, it would be impossible to have 2 bins close enough that we would both be able to read.
The other thing we considered was the fact that there's only 2 ways for the bin to go on. It's front facing or the back facing way. It can't go on the other side. So we know that we'll have a tag on either side of the bin so that it'll pick up the closest tag. Thankfully, this device will be able to pick up the closest ranging tag via signal strength. So we can determine what is our closest tag to avoid reading multiple tags in the event there are.
But if we wanted to read multiple tags, we could.
Yes. That's a functionality.
I mean, maybe because I can't see from here, but is the scale on the device itself?
No, it's like a big platform that goes on the ground.
It's a
For
4
the
foot by
music.
4 foot platform.
Yeah.
And it latches onto the.
It gets hooked up through a cable, and it goes in right here, and it's serial interface.
Yeah, that's just the display part that we're allowed to work with, and they have the actual platform, which is pretty heavy. Winery.
And I mean, compared to everybody else's design, this is a pretty big device. Like, what's the overall cost to make this prototype?
Well, considering that we mostly designed the the RFID and PSOC module system, we got the scale provided to us. That's already there at the winery. So when you're looking at cost, you're looking at the cost of the RFID reader, which is about 300 plus the PSOC modules and XB. It doesn't go over, I'd say, probably about 450, which is still pretty low form. Plus the tags. So tags are about $1 each almost. And at the winery, they have close to almost 100 bins, including ones that they get from other places. So with all that in mind, it'll streamline the process by making it easier for them to get data so they can have grapes in and out faster. So yeah.
Yeah, it's a good question because it depends on the customer. In this case, if item that they're working with is extremely highly valued, right? And the time is short, so they would be willing to pay significantly more than other customers would like. And for them to lose $1 million club, you know, they will easily pay whatever. It improves it.
What kind of information are you keeping track of about the
We're keeping
grapes?
track of the grapes themselves. We aren't keeping track of that. We're keeping track of the specific bin. So the bins will be essentially hard tags. So bin 1 will always be bin 1. And it's up to the winery to know what they have in bin 1. And then when they put bin 1 on the scale, the system will automatically say, okay, bin 1 weighs 2,050 pounds and it was weighed March 17th at 2:52 p.m.
But, yeah.
Our scope right now is that, and we had a meeting with Chick this week to talk to him about future parts of this. So this is just one stage of, the tracking system. So we talked to him about doing it upstream, where it goes from the vine to the bins. And what he likes out of that is he would like another interface so that they can distinguish what kind of grapes they are. So different grapes have different kinds can create different kinds of wines. So having that association helps him when he goes into logging data. This bin was attracted to this vine, which was used for Chardonnay. So that's very valuable information that he wants us to streamline.